Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 4. Section 1. Chapter 5. Topic 4. Understanding strain gauges in semiconductor packaging. Introduction. Strain gauges are essential sensors used in semiconductor packaging to measure mechanical strain and deformation in materials, components, and packages. These devices provide valuable insights into the structural integrity, reliability, and performance of semiconductor packages under mechanical loading, thermal cycling, and environmental stresses. This overview explores the principles, types, applications, advantages, and advancements of strain gauges in the context of semiconductor packaging. Principles of strain gauges. A. Strain measurement. Strain gauges operate based on the principle of electrical resistance changes in response to mechanical strain or deformation in the material to which they are bonded. When subjected to strain, the gauge undergoes dimensional changes, resulting in a proportional change in resistance. B. Wheatstone bridge configuration. Strain gauges are typically arranged in a Wheatstone bridge configuration, consisting of 4 resistive elements connected in a bridge circuit. This arrangement allows for precise measurement of strain-induced resistance changes and enhances the gauge's sensitivity and accuracy. C. Electrical output. The application of strain to the gauge results in a change in resistance, causing a corresponding change in the output voltage of the Wheatstone bridge. This voltage change is proportional to the applied strain and can be measured using instrumentation amplifiers or data acquisition systems. Types of strain gauges. A. Metal foil strain gauges. Metal foil strain gauges are among the most common types and consist of thin foil elements, usually made of materials such as Constantan or Karma, bonded to a flexible backing material, such as polyester. These gauges offer high sensitivity, excellent linearity, and wide temperature range capabilities. B. Semiconductor strain gauges. Semiconductor strain gauges utilize semiconductor materials, such as silicon or germanium, doped with impurities to alter their electrical properties in response to strain. These gauges offer high gauge factors, temperature stability, and resistance to thermal drift. C. Thin film strain gauges. Thin film strain gauges are fabricated by depositing a thin layer of resistive material, such as nickel chromium or tantalum, onto a substrate using techniques such as sputtering or evaporation. These gauges offer precise control over gauge geometry, high resistance to environmental factors, and compatibility with microelectronics fabrication processes. D. Bonded resistance strain gauges. Bonded resistance strain gauges are attached to the surface of the material being tested using adhesives or epoxies. These gauges are versatile, easy to install, and suitable for a wide range of applications, including structural testing, load monitoring, and fatigue analysis. Applications of strain gauges in semiconductor packaging. A. Structural testing. Strain gauges are used to measure mechanical strain and deformation in semiconductor packages, components, and materials during structural testing, including tensile testing, compression testing, bending testing, and torsional testing. These measurements provide insights into package stiffness, strength, ductility, and failure mechanisms. B. Reliability assessment. Strain gauges play a crucial role in assessing the reliability and durability of semiconductor packages under mechanical loading, thermal cycling, vibration, shock, and environmental stresses. By monitoring strain levels and deformation behavior, engineers can identify potential failure modes, fatigue life, and design weaknesses. C. Material characterization. Strain gauges are employed to characterize the mechanical properties of packaging materials, such as modulus, yield strength, ultimate tensile strength, and fracture toughness. These measurements guide material selection, process optimization, and reliability assessment in semiconductor packaging. D. Process control. Strain gauges are utilized for process control and quality assurance in semiconductor packaging manufacturing, ensuring consistent bonding, curing, and assembly processes. By monitoring strain levels during manufacturing, engineers can identify process variations, defects, and quality issues. E. Thermal management. Strain gauges are employed to measure thermal expansion and contraction in semiconductor packages and materials during thermal cycling and temperature changes. These measurements aid in thermal management strategies, package design optimization, and prevention of thermal-induced stresses and failures. Thanks for watching. Please like, share, and subscribe.